Hello students, welcome. In this session, we are going to see chords rule. Let us see what is chords rule. Right? Dr. Edgar F. Cord, after his extensive research on relational model of database systems, came up with 12 rules of his own, which according to him, a database must obey in order to be regarded as a true relational database. Right? So any database, if you want to call it as a true relational database, it should obey the 12 rules of Cord. There are in total 13 rules, but the starting rule starts from 0 and will come up to 12. Let us see the rule 0. It is foundation rule. The Cord's rule 0, that is foundation rule, states that the relational database management system must be able to use the relational model functionalities to organize, store, retrieve, and manipulate the data. This is the most important rule in all the Cord's 12 rules that every DBMS system should follow for it to be considered as a truly relational DBMS. So it states that every database management system must use the relational model functionalities. You already know what is a relational model, right? So those relational model functionalities it has to use either to store or to retrieve or to manipulate the data that is available in the database system. Going to the next rule, that is rule 1, that is information rule. The data stored in the database, may it be a user data or a metadata, that is data about the data, must be value of some table cell. Everything in database must be stored in the table format. So it is straightforward. Whatever you want to store, either the data or the metadata, that is data about data, like a table, when it is created, when the table was created, who created it, what are the rows, how many rows are available in the table. It's the data about the table. Table contains data, but it's a data about the data. The data about the data is called as metadata. Even whatever the either data or metadata must be stored in a table format. Right? This is a information rule number 1. And the rule 2 is guaranteed access rule. It says that every value that is there in the database should be accessible logically using the combination of table name, primary key, and attribute name, that is your column value or column name, right? So it should be logically able to access the each value of the cell through a combination of primary key, table name, attribute name, etc. Then rule 3, the systematic treatment of null values. As we know that the null values in database mean 3 different things. First, if there is a null value, we can assume it as a value unknown. That is, value exists but it is not known, or value not available, it exists but it is purposefully withheld, or the attribute not applicable, that is undefined for this tuple. That is to say, like assume there is an apartment number column in the houses table, but some independent houses will not have apartment number. Only the houses which are there in the apartment will be having apartment number. So the independent houses, for them this apartment number is not applicable, right? So this is nothing but attribute not applicable, undefined for this tuple. So you know that this null can be interpreted in 3 different ways, but for all of them there should be a systematic and uniform treatment. Null means null, no matter what it means, right? So that treatment should be there. If you don't give the systematic and uniform treatment for null values, then what would happen is the null could be viewed as three different things, and that would create an ambiguity. Thus, the null value should be given a systematic and uniform treatment. That is your rule number 3. Systematic treatment of null values. Rule number 4. Active online catalog. As you already know, the catalog is the data dictionary that contains data about the data. That is, it contains a metadata. So each database management system should provide this active online catalog to be called as a true relational database. So a structural description of an entire database must be stored in an online catalog known as a data dictionary, which can be accessed by authorized users. Users can use the same query language to access the catalog which they use to access the database itself. Right? So this is your rule number 4, active online catalog. Now let's get to rule number 5. It's a comprehensive data sublanguage rule. A database can only be accessed using a language having linear syntax that supports data definition, data manipulation, transaction management operations. So as you already might know, it's nothing but DDL, DML, DCL languages, right? So this language can be used directly or by means of some application, but the language has to be provided to access data, right? If the database allows access to data without any help of its language, then it is a consideration as a violation. So for any database management system to be called as a true relational database management system, it must have some language through which to access the data. If a DDMS provides that language, then that could be called as a true relational database management system. Rule number 6, view updating rule. As you know, views are the virtual tables created by using queries to show the partial view of the table. What is a view? View is a partial view of a table. Thus, that is, a views are subset of a table. It is only a partial table with few rows and columns. This rule states that views are also be able to get updated as you do with its tables. It means that this rule states that the view should also be get updated. They should provide an option to update the views as well as you do with the table. Failing to provide any updates on the views is a violation of this rule. Rule number 7, high level insert, update and delete rules. This rule states that every query language used by the database should support insert, delete, update on the records. It should also support set operations like union, union all, minus, intersect, intersect all, right? All these things you know already. All these operations should not be restricted to a single table or a row at a time. It should be able to handle multiple tables and rows in its operation. Assume if you want to delete a few rows, you should not delete one by one, because it should provide some query through which you should be able to delete the rows that you want to delete with a single command. And not only that, you should be able to run these commands on multiple tables. This multiple tables has given rise to the distributed databases. Okay, distributed databases are nothing but data is distributed across different tables and databases. These queries are run against different databases and tables to get the result. So it should be able to handle multiple tables and rows in its operation. If any database management system is not able to handle multiple tables and rows, then that is a clear violation of this rule. Rule number 8, physical data independence. Data stored in the database must be independent of the applications that access the database. That means that if you do any changes in the physical structure of a database, must not have any impact on how the data is being accessed by external applications. That is, if you move a data stored in one disk to another disk, then it should be seamless for the application that is interacting with the DB to access the data. That is, the application should not feel any difference or delay in accessing the database, even if it is moved from one disk to another disk. Right? So there should be total physical data independence. Your external application must not be disturbed if you move the data from one disk to another disk. Right? Then let's go to logical data independence, that is rule 9. The logical data in the database must be independent of its user's view. Any change in the logical data must not affect the application using it. For example, if two tables are merged or one is split into two different tables, then there should be no impact or change on the user application. The user application should not worry or should not have any impact if there is a logical change of the data. Rule 10, integrity independence. That is, the database should have its own independence to maintain its integrity. It should not depend upon any external factor to maintain the integrity of a data that is maintained in the database management system. The database itself should have some way of maintaining the integrity using the primary key or foreign key integrities or some checks, some constraints. Using those things, the database itself should have some integrity built in itself and should not depend upon external factors. So that's what this rule says about. Database should be able to apply integrity rules by using its query language. It should not be dependent on any external factor or application to maintain the integrity. The keys and the constraints in the database should be strong enough to handle the integrity. A good RDBMS should be independent of the front-end application. It should at least support primary key, foreign key, integrity constraints. Right? And let's see the rule number 11, that is distribution independence. That is, data might be distributed across various locations. Right? The database might be kept in different locations. One is Bangalore, another in Delhi, another in Singapore. The database might have been distributed across the locations, but the end user must not see that. For end user, should always get the impression that the data is located at only one site, right? So end user should not be able to see that the data is distributed across different locations. So this rule has been regarded as the foundation of distributed database systems. And the last but not the least rule, that is rule number 12, non-subversion rule. If a system has an interface that provides access to low-level records, then the interface must not be able to subvert the system and bypass security and integrity constraints. That is, even if a system provides low-level records handling interfaces, those should not give a chance to bypass security and integrity constraints of the DB. Otherwise, DB will get corrupted. If someone uses some haphazard commands, interfaces, if those haphazard commands actually bypass security and integrity constraint, then the data will be lost. Thus, if the system is providing low-level records accessing interfaces, then the DB should make sure that those commands, that low-lying record commands, should not be able to subvert the system and bypass the system security and integrity constraints. Right? Yes. Thank you.